Okay, good morning, everybody. Can everybody hear me? Thank you all for coming, and thank you to microXchg for inviting me here to speak. Before we start, this picture in the background here, does anybody know what it is? Yes? No. A little bit further south. So this is actually, you can see footprints here. See, these are actually fossilized footprints from the Devonian era, which was about 380 million years ago. And in the Devonian era, so then this creature, a tetrapod, which was kind of like half shark, half crocodile, crawled out of the water and put its muddy footprints in on the shore. And these footprints have been fossilized. So you can go there now and see the fossilized footprints from 380 million years ago, which is about 100 million years before dinosaurs existed. Yeah, I guess somebody else stepped on them afterwards, I'm not sure. So I was lucky enough to be in this location 2 weeks ago. Where this tetrapod walked is here on a small island in the southwest coast of Ireland. And it's a very interesting place to be in, actually, because in the same place 150 years ago, in 1866, the first transatlantic cable linking North America to Europe landed here. So you can stand in this one tiny island off the south coast of Ireland in a very remote location and compare 380 million years of biological evolution with 150 years of technological evolution. So I'm based just a short distance from here in Cork City. This is where Fourth Theorem, our company, has an office. We also have an office in New York. So a little bit about what we do then. So we don't build products of our own. We just work with other companies to help them do modern application development, so helping them to take existing platforms and go faster. And we use things like microservices and serverless to do that. And we also have a specialization in machine learning. So a little bit about myself then. So my name is Shanaghy. I'm a software developer, and I've been developing software across a lot of different industries for about 20 years. I was lucky enough to be able to start programming when I was about 8, writing BASIC on a Sinclair ZX Spectrum. So I really love to code. And even though I love to code, these days I try to build systems that have as little code as possible. So one other thing is that we've just released a book. So the CEO of Fourth Theorem and myself and Johannes Allman, we're writing this book on building serverless systems with AI services. So there's a discount code here for the conference, which you can use to get 40% off the book. You can actually use it to get 40% off any Manning book whatsoever. So you might like to take note of it. And I'll also be giving away a few free books at the end of the talk. So we're in the early stages of evolution in terms of software development. We've all probably dealt with unmanageable code bases and creeping technical debt and unpredictable deadlines. There's been many problems with software development. But for the past few years, I've really felt a sense that the industry is really evolving, that something is changing. And it's not really just to do with technology and new programming languages and new technologies. Something is a little bit different. We had all these problems in the past, but now I feel like software is less of a bottleneck for businesses, and it's seen more as a catalyst that can help them to go faster. So why is that? Well, I think the way we build modern applications is just fundamentally better and constantly improving. We've become kind of better at understanding that effective software development comes from a combination of culture and process and technology and effective communication. And the cloud has also removed barriers to let us go faster. So why is now so different? There has been a tipping point. So I used to try and solve problems in software, all these problems I mentioned, by improving the way I worked, by trying to improve my craft as a programmer, better unit testing, different frameworks, different tools, constantly trying to achieve technology perfection. But constantly striving for technology perfection is a fallacy because perfect doesn't exist. And it's kind of only when I started realizing that you can let go of the idea of perfection and start focusing on just getting things done efficiently, that things changed. So I started focusing on building product and not focusing on building software. So we're now in the era of the product mindset. And we've seen the open source movement and concepts like lean startup show us that it's better to dispense with perfect. Release early and release often. Do low-cost experimentation. Make shorter feedback loops. We're understanding how to do product discovery and including the customer in the loop, but to stay customer-focused. So our priority isn't really on building the product right and being perfect, but on building the right product. So this is actually really an exciting time to be a software developer because even large enterprises are starting to adopt this product mindset. And when our companies adopt the product mindset, that makes what we do as software developers matter. So how does this all relate to serverless? If the focus is going to be on building product and not on the tools you use to do it, then why does it really matter? You don't have to use serverless to innovate faster. You don't even have to use microservices. I might argue that it would help to do that. I'd strongly argue that. But it doesn't really matter as long as you take the right approach. And you won't necessarily innovate faster with serverless unless you take the right approach as well. So what matters is choosing the tools and technologies that will make you go faster. So when I started as a professional developer, things were very different. Things are slow and inflexible. We built software based on functional specifications created by different teams I never met. We had architecture specifications created by teams I never met. Everything was slow and labor-intensive. And what that meant was that the most frequently we could deploy was about every 3 to 6 months. And I never heard back from the customer. And then if you fast forward over almost 20 years of evolution, we ended up in the microservices era. And microservices gave us small units of deployment that allowed us to stay focused. We started understanding that our code was dispensable. We started getting comfortable with throwing away small units of deployment and starting again and iterating. Containers meant that we had deterministic deployments, so we could be very sure about what we were deploying into production. And that also mirrored our local development environment very effectively. And because we were using distributed systems, we got reliability and scalability. And this way of building technology actually allowed us then to change the structure of our organizations so that we had better communication and we had teams that were responsible for components of the system from inception all the way through to deployment and then beyond. And what we also got then was a bit of a burden of infrastructural investment. So in order to run and scale and manage microservices, we ended up almost building platforms as a service in every different organization to support that. So then came Lambda. So Lambda and functions as a service were kind of seen as an evolution of microservices, like just a smaller unit of deployment. So they were seen as an evolution of Docker or a replacement for what you do in EC2. And functions as a service have kind of become synonymous with serverless. So I want to move the discussion away from serverless just being about Lambda functions and functions as a service. The same rules don't necessarily apply. So you don't just take what you have in your container and move it to functions. And you don't just take what you have in your EC2 instance and split it up and move it into Lambdas. So when we're working with projects, even if you're working with a system that has a lot of legacy constraints, we like to say, forget about all your existing constraints in your existing system. We never build from scratch. So we always understand that if your system has customers and it's generating money, then it inherently has value. So it has business value. So you have to understand what the value is there and how to retain that and then enable you to go faster. So we try to get a picture of if you were starting from scratch today and all of your requirements were based on your real customer needs and not necessarily the constraints of the past, what would that look like? So you take a greenfield approach. So it gives you the freedom to have that vision free of your existing constraints And then we start working with the customer to decide, okay, how can we build a path to that vision? And what are the incremental steps, the kind of cellular change that we can affect over time to end up with that idealistic vision? And once you have that idealistic vision, then you can start to grow rapidly and really make a difference. So, what does a modern application actually look like? So I won't go through the architecture diagram, but I can describe it like this. So this system might be capable of ordering a pizza. Because it's 2019, your customer wants to order a pizza with a voice interface. So they want to say, hello, I want to order a pizza. And then they might have a conversation with this interface to determine what kind of pizza they order and send an order to a restaurant. And they need to pay for that pizza. So you need to integrate with a payment system. Then the restaurant needs to get a notification about that. And the user will get a notification to say that their pizza is starting to be cooked. And because it's 2019, they'll want to track the location of the pizza in real time on their mobile phone. So, and when the pizza is delivered, you might want to rate your interaction with the delivery agent. And an hour later, you might send a notification to the user asking them to rate their whole experience and how was your pizza. And all of this data is of interest to all the stakeholders. So the restaurant wants to know about how they're doing. You might want to do capacity planning on how many drivers you need to deliver pizzas next Saturday. And you might also want to do real-time analytics to see if there's any problems in the whole supply chain for pizzas. So the kind of integrations we have now and the kind of interactions and ways in which consumers of the system need data are very varied. So thinking about data and how it's accessed and how it's used is very important. But it's also worth taking, like these systems are very complex, right? Even just for ordering a pizza. So you have to look at like what does all this code actually do? And how much of our time are we spending building framework and infrastructure versus building business logic? And in general, as developers, what do we spend all our time on? I mean, our intuition as developers, if you ask yourself that, it's very difficult to actually think about it. So it's worthwhile sometimes actually trying to measure what you're doing and what components of the system you're spending your time on, how much coding you're doing, and what you're doing with the rest of your time. Some surveys have said that developers spend about 20% of their time coding. And that sounds like it's a very small amount, right, to a lot of people. But it isn't necessarily. Like if you're spending the rest of the time looking at your system in production and learning from it and using it to improve the system, that's okay. Or if you're using it to talk to the customer and find out how you need to focus your time for the next set of features, that's okay. But if you're only spending 20% of your time coding, then you want to make sure that you're spending it valuably. So with any new technology wave comes this promise of, okay, now you've got a new framework that allows you to focus on the business value. So you could understand that people might be skeptical, but I do think that serverless helps you to do that if you think about it in the right way. So think about, okay, what is actual business logic? What is the difference between business logic and undifferentiated heavy lifting? You know, you have this phrase these days, undifferentiated heavy lifting, and that's the stuff you're not supposed to spend your time on. That's what your cloud provider is supposed to do for you. So think about what is your business logic? Well, your business logic can be composed, like I've categorized it in these 5 things, but so you integrating to other systems, doing advanced calculations or transformations on data, doing delegation to other systems, your access to data. So how do you access data is critical to really how your system is unique. And then how you orchestrate the many different components within your system. Everything else really should be non-functional considerations. So your non-functional considerations are critical: how you monitor your system, how you secure it, reliability, governance, and compliance. But everybody has these same requirements, and these requirements are getting stronger and stronger and stronger. So while you need to dedicate time to ensuring that you are adhering to these, a lot of that time should be spent after you have shipped production, just measuring that. Right? Measuring that is very important. Spending time building code to achieve this should be avoided if you can. So let's look at these different types of business logic and then think, okay, am I really differentiating here, or is this something I can hand off to somebody else. Okay. So I want to also see, like, is Lambda in a serverless context, is a function the best way to achieve these things? So in the case of data transformation, you're just like doing kind of a map or a reduce, right? You're taking in data from one source, you're doing a transformation on it, and you're emitting it as an output. Or you're taking in data from multiple sources and you're doing some advanced complex computation on it, and you produce a result. Then you've got integration. Now, integration with third-party systems is something that everybody does, but the way in which you do it might be unique to you. So are you spending time on that unique part, or are you spending time customizing some cumbersome ETL system or trying to build your own ETL system in Lambda functions? Is that the best way to do it? Data access is always a funny one because it's something that in theory should be quite simple. You're taking data from a database and you're bringing it to the point where you actually need to consume that data. But for some reason, a lot of human misery seems to have emerged from the blob in between the database and the point in which you use it. There's a lot of ceremony around that a lot. Like, I've built ORM systems in the past and I've used a lot of them, so I know. And then you've got orchestration. So like taking data from one system, passing it to another, fan out to multiple systems, or then more kind of advanced business processes, so decision trees, where you've got logic in it, and these things can get quite complex. So given all these different potential categories of differentiated business logic, how do you approach that in a serverless context? Do you lambdify everything? So the phrase goes, if you have a hammer, everything looks like a nail, right? But there's a lot of reasons why you don't apply functions to every form of business logic. So let's talk about some of the drawbacks of Lambda and functions as a service in general. Lambdas are not good for developer flow right now. Docker, this seems like a step back from Docker, right? Because Docker gave us that unified deterministic deployment unit that you could run in your local environment and run in production in the same way. With Lambda, we still haven't achieved that. So for developer flow, you either have to deploy to the cloud or use some simulated environment that doesn't really resemble the same thing on your laptop. So you get a long feedback loop, and that's not good for development, because once you're waiting for anything to happen in development, you're waiting for something to compile, your concentration gets broken, your context switching, and suddenly you're wasting time. And then you've got physical constraints like the size limits. So even though you might be doing just a small computation, you might have a large set of library dependencies, because these things are massive these days. And then you spend your time trying to figure out how you can prune those dependencies so you can squeeze it all into your deployment environment. That's not the best use of your time. Then, of course, you've got issues with latency. It's not going to be the most high-performance environment because you've got cold starts and runtime overhead. And you also can't debug it very effectively in your cloud environment. Moving beyond that, then, one of the most significant things is that Lambdas and functions as a service in general are stateless. So you don't have access to a persistent storage. So every time you need data, you essentially have to go and fetch it. And this breaks the principle of data locality. So storage cost is cheap these days. Compute cost is fairly expensive by comparison. And the cost of transfer cost is also expensive, particularly just in terms of performance overhead. So you have to start thinking about, when you're implementing your unique business logic in a serverless environment, is it really worth the overhead of all this data fetching? So a typical canonical Lambda example is something that fetches something from an S3 bucket, performs an operation on it, and writes it back or writes it to a DynamoDB database or something. There's quite a lot of overhead in that. So serverless isn't really all about just Lambdas. The mindset about serverless is really about building product fast and using the managed services, the whole superset of managed services that will allow you to get those fast feedback loops and focus on the important things. So I prefer to think of serverless as true utility computing. So Lambda in AWS, functions as a service in general, is just one of these utilities. And in thinking about serverless architecture, it's important to be aware of the full set of managed services available to you, because there's opportunities there to dispense with a lot of coding, dispense with a lot of heavy lifting if you understand how the services work and what they're there for. So in the case of authentication and authorization, you've got Cognito, the different data stores that are available to you. Like, for example, AppSync shortens a lot of the work you need to do in terms of GraphQL and offline-online synchronization, serverless databases. And also in serverless, you spend a lot of time on identity and access management, and because you're dealing with small units, configuring the minimal privileges you need in order to run those. But when you're assembling a system that's composed of multiple managed services like that, the effect of that is federated state. So your state exists in multiple managed systems all across your cloud environment. And then your challenge becomes how to manage distributed state. So think about how to get your data in the right form when you need it, rather than constantly trying to prepare for all scenarios and then fetching on demand and aggregating constantly on demand. So where do you really need to compute the data? So to simplify that a little bit, think about the SQL versus NoSQL approach. So in a relational database, your schemas are structured. You've thought about how you're going to store the data. It's all very normalized. But what that gives you is the ability to do arbitrary queries. So you think about the design of the schema up front, and then you get the ability to use SQL to do different aggregations and selects across your data. So it's suitable for arbitrary data access patterns. Something like DynamoDB, on the other hand, is completely unstructured. So you can put in there whatever you want. But you really have to think about how it's accessed then, because you don't have an advanced query language in order to be able to query on it. So when you're looking at DynamoDB, if you wanted to do even kind of a relational type mapping in DynamoDB, you can do that, but you have to be very considerate in how you think about the secondary indexes you're using on the database. And then you can get very fast and scalable results, but only if you understand how to use it. And then you've got real-time events, so event streaming so that your different services can react to that if you're doing event sourcing, or just for real-time user access to data. So store with intent, so optimize for access. You definitely have to embrace polyglot persistence. So understand that you've got multiple databases across the system, and it might not just be DynamoDB and relational database. You might have Elasticsearch, S3 as a data store, various other ones. And then think about downsampling that data up in advance. So you aggregate as the data comes into your system so that it can be read very quickly, and you don't have to do the computational overhead at the point of access. Always keep your raw data as well. So your raw data is going to be useful for just observability of your system, but it's also going to be useful if you change how your access patterns, if you change how you store your data to accommodate your access patterns, because you'll never get it right first time. You'll have to be able to evolve, and having your raw data will allow you to rehydrate your data stores. So a few of the systems then. So I'm just going to show a few of these systems and what they can do. And it's really just to reinforce the idea that being aware of the different services your cloud provider offers will give you, kind of empower you to save a lot of time and know when you need to use these services. So a simple one to start with is S3 Select. So I talked about this case where you're fetching file from an S3 bucket to do some computation on it. You can use S3 Select rather than fetching the whole file, and that will allow you to do a select query on your data, just with a simple where clause to filter that data to the minimal subset you need, and then you can get 4 times improvement in performance. Athena then, so AWS Athena it's a little bit similar, but quite a lot more advanced, in that you can do arbitrary analytics on your data warehouse. So if you've got large volumes of raw data in your data warehouse, you can use this serverless environment to do very complex aggregations on those large volumes of data. So it allows you to do very complex queries. And I've used it for analyzing logs. So if you collect all of the logs from your CloudWatch from all your services and you store those in a bucket, you can just bring up an Athena environment and you can do queries on those. So if you don't necessarily want to use Elasticsearch or whatever other log system you use, it's a nice way to do it. So then you have AWS Glue. So Glue is a really nice ETL platform. So it saves a lot of the overhead that you might have in building or customizing a third-party ETL system. So the way that works is by discovering your data at rest in your data warehouse, and it can build a catalog of that and categorize it for you. And then you can use Scala or Python to do computations on that. And then you can assemble these computations into fairly advanced ETL pipelines. So it's very easy to get started with, and it's very good for a lot of different use cases you might have for ETL. So one example is in cleaning data and preparing it for machine learning and getting it into the format you need. I want to talk about SageMaker, so SageMaker is a machine learning environment from AWS again, but the reason I want to talk about it, not everybody necessarily believes they have use for this, but the companies seem to be divided into companies that want to use AI but don't have a use case, and then there's a lot of companies who have a use case but don't understand that they actually have value in their data. So I think it's always worthwhile looking at these things and understanding that what they can do. And SageMaker really is very powerful. So it has a large library of pre-trained models that you can use. One example of a recent project I did was a customer who has an IoT platform. So they have a lot of different IoT devices that are collecting sensor data. And the sensor data is coming up through the IoT core and is being stored in a DynamoDB database so that the end users can access that sensor data on a mobile phone. It's quite simple. But these sensors are also taking pictures of their environment with a camera. And every couple of hours, they upload those pictures to an S3 bucket so that we can do some analysis on them. And they actually pre-trained a machine learning model on an off-site GPU cluster. That was the stage it was at when it came to us. And they wanted to figure out how to get this into production. So a lot of people who are very good at building machine learning models and training them, but getting it into production is quite a different story. And it can be quite complex. So what we did was we put together this fairly simple machine learning environment with SageMaker and Lambda. So after the images are uploaded on a schedule, we process the images and downscale them into two formats. So one is for display on the mobile device, and the other is for image processing for the machine learning inference model. So when we have them all down to the right size, then we kick off a batch machine learning inference job. So at this point, we have no machine learning infrastructure. So the first thing this Lambda function does is it creates a SageMaker environment. And that's a containerized machine learning instance. So it uses actually a pre-existing PyTorch container from AWS, so it's quite simple. The actual machine learning model then, so they just check that into Git, and when it gets merged to master, then the continuous deployment pipeline syncs that up with the S3 bucket where the model is. The code is deployed into the serverless environment with CloudFormation. So then when the machine learning inference job is running, it starts that SageMaker endpoint, points it to the model, and then you've got an entry point function which says, this is how we take the image data, convert it into the vector format we need, do some normalization on that data. So then we just take that data. The endpoint itself takes just a few minutes to start up, and then we can start throwing images at it. So we throw the images at it one by one, and we get all the categorization data back. We put it into DynamoDB. A couple of minutes later, all the images are processed, and we shut down the SageMaker environment. So we've got production, very, very good use of kind of on-demand compute there, because it takes just a couple of minutes to run all of the image inferences, and it costs like a couple of dollars a month or something. Then on the real-time side, you've got Kinesis data analytics. So Kinesis stream, if you know it, it's a little bit like a Kafka stream. So you can hook up your Kinesis data stream to an analytics, Kinesis data analytics pipeline. And in that pipeline, you're taking your streams of data as they come in, and you can use either SQL or you can write Java code that aggregates that, so you can do kind of windowed averages on your data in real time. So then you could put those into an S3 bucket, or you can also then use a Lambda function to take that aggregated data out of another stream and persist it to your DynamoDB database. So that could be for on-demand access. But if you want real-time access then for the end user, you could use DynamoDB streams and have it hooked up to a WebSocket so that somebody's getting a real-time visualization of that aggregated data. So when I talk about data locality and computing up front, this is a nice way to do it. I'm not going to talk about authentication and authorization too much, but I would say that if you've got very bespoke and different authentication and identity requirements, it's okay to do some customization. But for me, for everything else, there is Cognito. And Cognito has saved me a massive amount of time on many projects. I've spent a lot of time in the past building login and sign up and authentication and authorization systems, which I'm sure had problems. So I'm very glad for that. Okay, so then lastly, I want to move on to orchestration strategies a little bit and talk about how you do that, because in all distributed systems, this is complex. So I just want to talk a little bit about how that relates to serverless. So people talk about, might have heard about choreography versus orchestration. We've heard that a few times in this conference. So I like to talk about explicit versus implicit. So explicit orchestration is when you have some central controlling infrastructure that delegates to other services. And implicit is when each service is responsible for its own thing and how it reacts to events and how it emits events. And then your orchestration isn't controlled from one central point, but it's a product of all of those event reactions. So when it comes to explicit orchestration, you can look at using Lambda. So in a Lambda function, you would basically just fire off requests to different services and synchronously invoke those services, or asynchronously await or whatever. But the problem with that is that while you're waiting for all those services to execute, you're just paying for wait time. And that's something that you have to think about with functions. With functions, if you're just waiting on I/O, you're still paying for computation, which really doesn't make sense if your I/O is quite intensive. So there's also AWS Step Functions. So this example is like a state machine for biometric identity verification. So say your bank wants you to log into a mobile app. You log in with your username and password, but they also want to check that it's really you. So they ask you to take a video with your phone, and they'll give you a random sentence to read to make sure that it's really you in real time. So the video gets recorded and it's in an S3 bucket. So then you would kick off, and you can have 2 steps in your step function at the start to fire off image recognition to check your face against a Face ID library. And then you might do some transcription on the audio to make sure that you're saying the right sentence. And when you have the result of that, if something goes wrong, so if either of those 2 things fails for some reason, you might divert the attention to a manual operator who will do that job on a terminal. Or you might take the output of that, the machine learning part, and say, okay, what's the probability that it really is that person? And if it's below a certain threshold, you might again, delegate to the manual operator to look at it. So you would kick off like a message on an SNS topic or something for that manual operator to do the manual inspection. And then you would have to poll for the result. So step functions allow you to do that. And then at the end, you've either got an identity failed, or identity verification failed, or succeeded, and you issue a token or something. So with step functions, it gives you this nice visual layout. You can see the flow of data through your system, and it's declarative, and you have, I suppose, that visibility you need, and it's that coherence. The disadvantage is that as your requirements get more and more complex, this can become like a tight coupling effect, and you've got too much complexity in this one location. So the implicit approach is the opposite to that, where everything is event-driven, you do everything in isolated steps, and it's a little bit more reactive. So then, in that case, your state machine isn't declarative, it's more emergent from your system. So you might design it up front, but you think about everything in isolation, and you don't get to visualize it until you run the system and actually start passing data through it. And then you can use X-ray or whatever open tracing platform you want to visualize how that interaction is actually occurring and where there might be events. Also think for orchestration about using the client for that. So if you've got isolated microservices, you don't have to do composition of all the data on the server before returning it to the client. And it depends on the context and the user needs. But a lot of the user interfaces, it depends on the device and the context and the user. So it actually, in a lot of senses, makes sense to let the client device do a lot of that orchestration, particularly in terms of data composition. So separating your requests from your responses and having real-time streaming data up to your client and letting that client application, client applications now are all about state management as well and how you unify complex states in order to render the right view. So it doesn't necessarily have to be like that. And you can also think the GraphQL approach as well. So you keep your services separate, and then you have a GraphQL API that allows your client to have some control about how the data is fetched. So when it comes to delegation, a lot of microservices are composed, and anyone who's developed microservices has probably seen themselves develop very simple microservices that really just take data from one source, pass it on to another. And they might just do something like authentication or an authorization check as part of that, just to have some level of security, and that's why it's there. Or they might do some validation on the data, and they might do some transformation to convert the request into a different format. But you can actually do this with API Gateway and no Lambda function. So API Gateway in Lambda allows you to take an API Gateway endpoint and create it in such a way, so you define your authorizer as you usually do, even if you have a Lambda function at the back of it. And then you can use a velocity template to map the request in the format it comes in to the format you want to send to the downstream service. And you can also define a JSON schema on the request. So it's doing validation for you, it's doing data transformation for you, and it's doing authorization. And you don't need to use a Lambda function for any of it. And the benefit of that is that you don't get the overhead of the Lambda function invocation, and you don't have the cost of the Lambda invocation, and you don't have to maintain a Lambda function. And with AWS API Gateway, you can actually, instead of picking another HTTP server as the backend for your endpoint, you can just pick any of the available Lambda, any of the available AWS services. So this is a very neat way of getting data into your system or getting data out of your system without any overhead. So you just pick whichever service you're integrating to. So if you pick DynamoDB, you can say, map this HTTP RESTful post endpoint into a DynamoDB put item request. And then you just translate, with the velocity template, you translate your incoming request to the request that DynamoDB needs for its put item. And you can do the same with the response on the way out. So you could do it also with a query. You'd have a GET request that maps to a DynamoDB query. And it might save you again some function invocation overhead and the overhead of maintaining a Lambda function. So you could also imagine doing this to push a message to an SNS topic or to push an event onto your Kinesis data stream. And that's what it looks like in the console. When you're manually creating an API gateway endpoint, you can pick from the drop-down any of the services. So then, wrapping it up. So if functions as a service is not the most important thing about serverless, what is? Well, the product is the most important thing, really. And then automation, so the continuous deployment pipeline and making that as fast as possible and as streamlined as possible so that you're getting to production quickly and getting there fast. Your iteration speed so that you can constantly measure and improve and redo. Understanding that your things are expendable. So experiment, try things, throw them away, go again. Know all of the managed services so that you have better knowledge about the decisions you make, and you're not just adhering to the same technology patterns of the past, that you're open to new options. And really the most important thing is everything that happens after deployment, because when you think about it, everything you're doing up until that point is really just preparation. And I saw this tweet from Charity Majors 2 days ago. Every moment you spend in production, you learn valuable lessons about how your code interacts with users and infrastructure. And this was part of a long thread, and one of the other things she said was, every moment you spend before production, all you're doing is learning false assumptions and bad intuitions about how your system is also behaving. So I thought that was quite interesting. So one more thing before I finish. So even with all these managed services and everything, building a serverless system from scratch, there's still a lot of decisions to be made. It gives you a lot of options, so sometimes you can be overwhelmed by decisions, and it's quite frustrating. So we're trying to take all of the learnings we have from building different serverless systems, and we're creating an open source project called Slickstarter. And it's a full project. It's a full stack project. It gives you an opinionated project structure, a continuous deployment pipeline with cross-account deployments, access control, and unit tests, integration tests, and end-to-end tests against the UI as well. So it'll give you something to either learn with or use as a template to get started on your own project. So if you're interested in that, if you want to use it or contribute to it, we'd be absolutely delighted. Just talk to me or tweet me or follow me on Twitter. I'll be talking about it definitely when we announce it in the next couple of weeks. So with that, thank you very much for listening.
Thank you so much, Owen. So we have time for questions. So do we have questions? Yes. You get the microphone so that we can record it.
Hello. Yeah, I have one question. Somewhere on your slides, you've mentioned Aurora Serverless.
Yes.
Aurora.
Yes.
However,
Aurora Serverless. Yeah.
But how can a database be serverless?
So how can a database be serverless? So Aurora database, yeah. So in terms of how it's implemented, I can't tell you. So you'd have to ask the AWS Aurora Serverless team for that, I suppose. But Aurora Serverless Aurora Serverless is kind of on demand rather than creating. You can create an RDS instance for Aurora. Aurora Serverless just allows you to do that on demand. So you declaratively create it, and it dynamically scales for you. So you don't have to think about what the instance size is or any of that. So it's dynamic in that sense. They also have an interface which is quite nice, I think, which is in beta at the moment, called Aurora Serverless Data API, which allows you to just access the data in that using a HTTP endpoint rather than having any middleware in between. So interesting to watch.
Do we have another question? Sorry. Oh,
yes. Hi. I know that serverless is like the cool kid in town right now, but as you said, there's some backdrops like development flow and debugging and all that.
Yeah.
If I'm in a team where they come from the monolith perspective, changing them to a microservices mindset, and then serverless is going to be hard. What would you think it would be like the business scenario that would be good for me to fight for applied serverless, and which I shouldn't avoid like this effort?
Yeah, it's a good question, and it's not a simple question to answer. Sorry. So there's two things. There's convincing the peers and other developers on the team and the other technology stakeholders. And for that, I think an incremental approach where you start introducing elements of serverless in less critical parts of your application helps. So showing how it can be used to automate more operational parts of the system, like backups or small jobs around the edge. And that's how I started using Lambdas and things like that in the beginning, was just to avoid having to create infrastructure to do very simple operational tasks where you might have used scripting before. When it comes to business, it's realistically, so it will come down to a cost, right? So it has to ultimately come down to cost. So I think it's worthwhile spending some time trying to figure out what the cost savings might be. So to do some calculations on, if you can estimate how expensive your current system is to run, both in terms of the operational cost, the number of developers, the number of bugs, advantages that you might get with serverless in terms of that cost elasticity. I think developers are going to have to get more and more capable at doing, what they call FinOps, trying to understand the costs of their architectures as well as the technology, because you have to make decisions based on that. And I think just like with moving from on-premise or VMware to the cloud, customers are now at the tipping point where most of the customers out there are understanding that you can't ignore the cost benefit of cloud. And I think the same will happen with serverless. When you see that all of the infrastructure you have now, you're paying for it even when it isn't being used. If you can do that calculation and actually work it out, even if it's just an estimate, then you can start to get attention from business stakeholders in the company.
Do we have another question? Before we come to the other question, yeah, go ahead, you can take the microphone. But I have a schedule change announcement just before we come to the other question. So we have 2 talks that's going to be switched. So we will announce it on Twitter and on our website as well. But just for your information, so there are 2 talks. Jan de Vries at the morning from Gallery is switching with Thomas Derimond in the afternoon in this loft, just for your information. And let's go to the next question, please.
You talked about business. One question that a lot of business people especially have, if you get into this vendor lock-in, and especially larger companies, I think, are moving to Kubernetes to especially have this abstraction over clouds and being able to switch clouds, because there's a lot of diversity in APIs and services still. Between the different cloud providers. What is your answer to that?
Again, it's a very real question. I think it's a valid question, but it's one you have to actually try and empirically analyze and quantify. So if you can even, again, rough back of a napkin calculation, work out what is the cost of switching cloud vendors versus what is the cost of choosing one and moving fast with that right now, then you can start to make a decision. It's very difficult to you can be held back from making a decision by just the fear of vendor lock-in. But at the same time, we all have lock-in in our systems. We all make technology choices, even if it's the 50 different libraries we choose on a daily basis. We all have lock-in, and we all have a switching cost. And even with open source components, something might happen to that project in the future, which means we have to move away from it. So I would kind of say, embrace the lock-in. Just go for it if you can. If you have a real business requirement that means you don't want to lock into one cloud vendor, then it's fine to start thinking about abstraction. But there is massive overhead with that. So you have to make a conscious decision. Am I really prepared to sacrifice moving fast in order to have that potential scenario covered in the future?
So we have time for another question. Do you have some questions left? Okay.
There's one in the corner,
there
I think.
in the back. So the microphone is coming. Can you?
Thanks a lot. First question is, so we have all the serverless things or functions for most of the main cloud providers, like AWS, GCP, whatever, Azure. While some companies will not be able to go to clouds like anywhere, anytime, because they are governments or banks or some other heavily regulated industries. So can you advise any kind of open source serverless technologies or platforms that guys can install on premise or can install in the clouds if they don't trust implementation of Lambda, or they need some tricky another runtime which is not supported?
Yeah, so there are more offerings in this space. I'm not the best person to answer the question because I haven't used any of them, so I don't know what the experience is. I mean, it isn't, you can't, there are things like Kubeless, and there's a few others that are, Kubernetes-based serverless environments. So they give you that elasticity and more finer-grained control about what you're doing and handle the scaling for you. It's not really truly serverless because you still have to manage the server underneath it, but it might be the answer to your question. So, yeah, does that answer your question in some way? I don't have the experience with them to actually judge them.
Okay. So thanks a lot. So we are at the end. So thanks a lot, Owen, again, and give him a warm hand of applause, please.